How many people here have ever used GitOps or have heard the word GitOps? So yeah, I think we are relevant. So hello everyone, my name is Anuj, and I'm presenting uh, like a talk on the topic breaking GitOps. So a a little bit about me. I'm a senior SRE at a company called Ring Central. Also, I'm a AWS community builder. And I provide sometimes mentorship for people who want to make career in SRE or in software professions. And I have provided some open source contributions into cloud native, a couple of cloud native tools. Also, good to be back in Boston as I'm alumni of Northeast. You can use the QR code to connect me in future if you want. Uh, to begin with, what GitOps is. GitOps provide declarative infrastructure where we consider Git as a source of truth and use it to deploy our application. And all the Git application so far I have seen use something called controller, and that used to reconcile and fetch the data, the infrastructure, declarative infrastructure configuration that we have provided in the Git, and pull the configuration from there and try to keep matching if within the cluster, if it's there or not. But as you deploy GitOps up to manage your infrastructure, everything is good. But with time, your team is growing, your product is growing, and there may be more changes are happening at the same time, and or you're running some bad jobs. It could be for multiple reasons. The controller from GitOps that we just discussed started having some resource issues, and it might be crashing, and it may be getting like out of bound errors, out of bound memory errors, and then you might be trying to figure out what to do. So there are like multiple jobs a controller does, and let's see. So So it can happen because your application is growing, you are adding a lot of new features, and multiple people are working. There are changes happening in lab, happening in stages and production. At the same time, some QA teams are working. And the single controller, if maintaining everything, then it can get overloaded sometimes, and then it's a problem. And it can be happening because of the multiple reasons. Maybe your controller architecture having limitation that you have not, that you have initially may not be using caching if it provides caching, and you may be not using in configuration parallel approach. You're using maybe single threaded options in the configuration, and maybe your configuration changes you are doing, they are too big at the same time, and they're providing too much overload on the controller. And could be like too many environments on the one GitOps instance is the reason. Another possibility, and that is making your repository because of too big. So from these situations, we can say we can solve these problems, and there can be no resource issues as well. So we know these could be the common signs of the problem, and there can be, and one of the reason could be the reconciliation times is too short, and we are frequently trying to check from our GitOps application or controller to pull or the match configuration on our Git version controller, GitLab, or GitHub, or whatever you're using. And that can lead to failed deployments, memory leaks, and all that. So we get the idea now, the problem could be happening. So what we can do in that situation, initially, if we are monitoring and if we are seeing, we can initially just increase the memory and CPU resources, and that's good. But if we can do that up to a limit, and if still keep giving problem, then another approach we can do is we can just split up the application or the environments into different GitOps instances, right? And the third approach could be we can just shard the controller. Now, if you might have heard about database sharding in the past, and what it has to do in GitOps. So in GitOps, we, instead of splitting your repo into multiple GitOps instances, we can just use the same instance and divide the workloads into different controllers itself, and that is sharding. So, so it will going to benefit us in a way. We are distributing the workload, and we can it will our reconciliation time, even if we have shorter or we don't want to increase it. This is how I have shown. So there was a one controller which is red, and it was getting overloaded, and then we split it into, after sharding, the 3 controllers, and we're not getting the same problem. It's kind of a horizontal scaling approach, we can say. So, so we discussed these benefits on that. So it can reduce the resource usage and everything, and we can, and then your team is working in a will be getting less problems, or the other your stakeholders from the DevOps or SRE working on that. They're getting less problems, and the pipelines are not failing, controls are not getting crashed, and all this is good. Now we come to a point here. Who know what are these 2 logos? Both of those. Yeah. So these are the most common in the cloud native world GitOps tools, and I'll discuss these and compare them from the perspective of sharding. So if we go with the Argo CD, Argo CD provide sharding approach on a cluster level, meaning you may have a 4 cluster, for example, maybe 1 in lab, 1 in stage, and 2 in production. I'm just giving an assumption. We can divide it another way also. And Argo CD use a stateful set kind of approach. It will build the way it will divide also will be numbered. It's not a random hash kind of a thing. When it will show the output, I'll show you what I mean by that. And so each controller will have either 1 or 2 controller. So that kind of workload it will get, the way we were going to divide it. So Argo CD provide multiple algorithm we can use for our sharding approach. We can use this first sharding approach, which use just a formula, use the hash of cluster ID, and it will take modulo of the number of replica of the cluster we have. The round robin is if we have heard about it, used a lot in a lot of load balancing algorithms, and in the case of load balancing, we are just if we have like a 4 cluster, for example, there can be 1 cluster on the first controller, 2nd cluster on 2nd controller, and 3rd on 1st controller again, and 4th cluster on 2nd controller. So it's just like trying to balance it based on the request it's getting. But and it looks like a good approach. And the other one is constant hashing. It's also a very common algorithm in the load balancing, and it uses a hash based on the request that is coming, that divides the cluster by taking the hash of the every cluster. In the manual assignment, we manually label kind of annotation similar to annotation we provide in our cluster configuration, and we just assign the shard number to the cluster configuration, and that way we can just give where it should go. So why is it we even need to do it is maybe we have 2 small clusters and 1 big cluster. That way we want to distribute in a different way, not in a dynamic way. There's another dynamic distribution algorithm which is not using stateful set. So you see a couple of those have stars: round robin, constant hashing, and dynamic distribution. and they're all in alpha feature. They're not currently stable, and for this reason, it is not advisable to use them in production. But Argo City currently providing at least them, so it's great. Maybe at some point of time they'll be stable. I hope so. And the way how after sharding we can see how our cluster are sharded with the controller. As you can see, the shard 0 is assigned to cluster. So shard 0 with number 0 is assigned with to cluster, cluster 1 and 3. So in that way, if you can see, all others have one cluster assigned, only shard 0 has 2. So if we see the kind of way they are numbered, one shard has to get to cluster, and that can create a problem. Maybe if we are using any dynamic algorithm we discussed or out of the manual one, it could do not a it'll do the non-uniform distribution based on if the clusters are it doesn't check basically a dynamic algorithm if the clusters are big or not. They're just numbering it, right? So the problem here is so how I mean, yeah, this could be the in that case of cases, if we want to divide them based on smaller cluster or larger, we can use maybe a manual approach. So that already tell us what the problem with the sharding approach algorithm that Argo City support. First is it only provide support for cluster level assignment, and Argo City also uses Redis, but only the controller can be sharded. You can't. The Redis is not going to be part of it. And in case of example, the legacy algorithm, first algorithm, it can also do uneven distribution in the round robin. Every time there is reshuffling or the algorithm runs for a different reason, any cluster, you're adding new cluster, or in any reason when the algorithm going to run, there can be like a redistribution between the controller assignment, and that can create some problem in stability of the workloads. In the constant hashing, we can see it is also bound to be uneven workloads, and so in that case we can see manual assignment is more stable, but it's add more operational overhead. In the case of the Flux CD, we can do more granular approach. We can do resource level sharding. So that is kind of a more better approach, but we can do it through like labeling like that. We can see in the Flux CD, there's not just one single controller, or we have multiple controller. It uses microservice approach for controller, and not all of them support sharding. So that is the demerit with the Flux CD side. With that, we can say the challenges are there's no automatic or the dynamic algorithms available with Flux CD, and it increases our operational overhead we need to match, and we can need to see it's. So basically here we're going to assign it sharding controller assignment based on the application, not on the cluster. So that way we can compare and we can say which is the better. If you want to go with, it depends how your infrastructure is. So so better is Argo City has more dynamic algorithms currently available, and if you want to divide your distribution based on cluster, then Argo City is good. In case of Flux City, if you need more precise control based on the application resources, then Flux City is better. So the good point to how we should monitor is to monitor your controller for the resources so that we can take the action before even you start having issues. So that's all from my side.
Hi, yeah. So I was working over the summer as an intern for the OpenShift GitOps team. So I was kind of working a lot with the Argo, it's called ecosystem. And so one of the things I kind of noticed was there's a lab project that's kind of in the works called Argo Agent, which is kind of working to redefine the multi-cluster story for Argo CD. I was just curious if you've heard of that or see if that's helped with sharding at all.
So you're saying supporting multi-cluster in Argo City?
Yeah, it's a project called Argo Agent.
I think we can already manage multi-cluster. It's been a long time since we can manage. It's not a problem.
From what I understood when they were talking about it, is it's trying to add a kind of make it a little easier.
So what I'm trying to say here is, initially when you run one cluster or maybe multiple cluster you're managing with your Argo City, and if you're having like resource issues, then by default there is one controller running in Argo City, and you want to split up. So controller is like a backend you can think of way for application, and it is performing multiple tasks like you're running in Git like Helm, you're using it and you're using customize, and it has to render gives configuration of like the vanilla Kubernetes configuration out of it, and it has to pull from Git and all that responsibility. And if there are multiple changes that are happening at the same time, it has to do all those operations and it can get overloaded. So you can divide the responsibility between two controllers, and that way the workload on one application can get one controller can get a little less.
Okay, so I'm just probably misunderstanding. They're probably two separate things then.
Yeah. Okay.
Thank you.
Okay. Thank you very much.